Well, hello. Hi there from this oddball corner of the internet. I'm Jennifer, and here I take a deep dive into all things mysterious, odd, and strangely beautiful when it comes to science. So, dark matter, dark energy, black holes. Yes, this is how I'm starting my channel, in the thick of it. So, could dark matter be primordial black holes? Is a question that is seriously being considered in modern cosmology. In those first moments of the universe, it's theorized there might have been another ingredient in the cosmological soup: black holes. These black holes from the very beginning of time, also known as primordial black holes, could still be lurking around today in the form of dark matter. Although the first evidence for dark matter was discovered in the 1930s, it wasn't until the 1980s that astronomers became convinced that most of the mass holding the galaxies together was invisible. For 2 decades, theories were proposed and challenged, but it wasn't until the early 21st century that the double dark standard cosmological model was accepted, in which cold dark matter plus dark energy make up 95% of the cosmic density. The challenge now is to understand the underlying physics of dark matter and the nature of dark energy. Hypothetically, the fact that dark matter is cold, meaning the particles move extremely slowly compared to normal matter, allows the dark matter to form gravitationally bound clumps. Astronomers think most dark matter is cold dark matter, as this would allow for matter to form galaxies. Now, according to modern models of physical cosmology, there exists a basic unit of structure in the cosmos, and this is called a dark matter halo. According to modern models of physical cosmology, there exists a basic unit of cosmological structure called a dark matter halo. It is a hypothetical region of space that is decoupled from cosmic expansion and contains gravitationally bound matter. Now, a single halo can contain viralized clumps of dark matter called subhalos. And within these subhalos, it is unsure whether it exists as just solely dark energy, dark matter, or perhaps something else. It turns out that 68% of the universe is dark energy, with dark matter making up 27% and then normal matter making up 5%. So, coming around to dark energy. One explanation for dark energy is that it's a property of space itself. Now, Albert Einstein was the first one to realize that empty space is not nothing. The first property of space that he discovered is that new space can come into existence. Then, one version of Einstein's theory of gravity, the one that contains a cosmological constant, makes a prediction. Empty space can possess its own energy. This is essential because this energy is a property of space itself. It would not be diluted as space expands. One possibility for dark energy is that it's some sort of dynamical fluid or field that fills all of space but has the opposite effect of cosmic expansion in the universe. Another explanation for how space acquires energy comes from the quantum theory of matter. In this theory, empty space is actually full of temporary virtual particles that continually form and then disappear. But when physicists try to calculate how much energy this would give space, the answer comes out wrong. Wrong by a lot. The number came out to 10 to the 1/20th power. That's a 1 with 120 zeros after it. It's hard to get a number that wrong, so the mystery continues. Now, another thing we have to consider is that Einstein's theory of gravity might not entirely be correct and might be missing something. So, in science, it's vital, very vital to keep an open mind. But the hard part is making sure that it can still function and agree with observational data. Without dark matter, the universe just wouldn't look the way we observe it to be. The evidence comes from gravitational lensing, which is the distortion of light caused by space-time curvature. Clusters of galaxies bend light more than their mass can account for, so something else must be there to bend space-time that strongly. Now you may ask, what is the point in trying to understand dark matter, dark energy, black holes, and other mysterious oddities of the universe? Let me start with this. We came from stardust. From there, the formation of stars and planets allowed for complex molecules to form into bacteria, which then evolved over 1 billion years to blossom into what we are now, humans. Do you ever feel awe, or perhaps maybe it's wonderment, at how truly lucky we are to be here in this universe, on this planet, to witness this fleeting spectacle we call life? Through probability and odds, we have evolved an organ, our brain, that allows for the capacity of time travel, whether it's thinking of the past or imagining the future. Being aware of this universe and having the ability to understand and decode everything which surrounds us, wouldn't it be a waste to toss aside this Pandora's box of wonderment that could lead to whole other realms? So, you ask, what is the point? It's perspective. And with perspective, you have the key to open so many doors. So this is my first YouTube video, and I would greatly appreciate it if you could help me pass on more strangely cool videos by liking this video and subscribing to my channel. Thank you so much for watching, and I'll see you very soon.